So in equation of a wave, uh, when we need to find out velocity of any point, for example, let's say you have to find out velocity of this point, or as this point, or as this point. If any point velocity you have to find out, so maybe this point is moving up or down, and wave is moving along x-axis like this one. But particle always oscillate along y-axis, so they are oscillating like this one. So at particular point, for example, if I'm asking for point 1, where this particle 1 is going, then this is point 2 where this particle 2 is going, this is point 3 where this particle 3 is going. So for that we have a derivation of a velocity t. This is the formula a sine kx minus omega t plus phi. And if I differentiate this formula with respect to time, so what I'll get, dy by dt, that is equal to a omega cos kx minus omega t plus phi. And this is partial differentiation, so we can write this dy by dt, we can simply write like this one, partial derivative, symbol is this one, d delta y by delta t. But in this one I will use dy by dt only. So once again, if I differentiate this one, so okay, so this one I use dy by dt only, so I differentiate this equation with respect to t. Now if I differentiate this expression with respect to x, so what I'll get, a k cos kx minus omega t plus phi. And for this one as well, I can use this form. This is partial differentiations. If I write, so it should be like this one, dy by dx, del y by del x. Now, if I divide equation 1, this is equation number 1 and this is equation number 2. If I divide these two equations, what I'll get, dy by dt divided by dy by dx, that should be equal to minus omega by k. And omega by k is the velocity of a wave. So we can write dy by dt, that is velocity of particle, is equal to minus velocity of wave into dy by dx. And dy by dx is slope of this graph. So if I take this one as x-axis and this one as a y-axis, the slope of this one will be dy by dx. It means velocity of particle, whenever you have to find out, the velocity of particle is equal to velocity of wave multiplied by slope. So for better understanding, if I take example of this one example of this here, and I am marking so many points. First point is point 1, and this is point 2, and this one is point 3. So where this point 1, 2 and 3 are going, so we know the formula for that velocity, Vp is equal to minus velocity of wave into slope. So velocity of wave remain constant, that velocity of wave is equal to f lambda, that remain constant in this case. So if I need to find out where this particle 1 is moving, this particle 1 where it's moving, in that case, if you see the slope of this one, is 0. And if slope is 0, it means velocity of this one will become 0. So what's the velocity of this particle? 0. It means 1 is going nowhere at that instant. It means velocity of that particle 1 is 0. Now, if I ask velocity of particle 2, so if we see the slope of that particle 2, and slope of this particle 2 is again 0 because this line is parallel to the axis. So slope of this one is also 0. If slope of second one is also 0, in that case velocity of second particle will be also 0. Now look at third one. So in case of third one, if I draw slope will be like this. See, it will be like this. It means this angle is less than 90 degree. If that angle is less than 90 degree, it means if I write this formula once again, Vp is equal to minus Vw into slope, and if angle is less than 90 degrees, so slope has to be positive. इसका मतलब इसका slope will be positive, slope of this one will be positive, And if slope of this one positive and when negative sign is there, so simply multiply by negative sign. It means finally what we are getting, Vp is negative. Vp negative means this particle is moving downward. So if we see this particle, it's moving down. Now I take another particle. This one is one particle. This, let's say this one is final particle F, where this particle is moving. Again, if I draw slope on this one, so slope will be like this. Slope of this one will be like this. This one will be slope. So this slope is more than 90. It means slope become negative. So if I write this formula once again, Vp is equal to Vw into slope, and right now slope is negative because this angle is more than 90. Which angle? This angle is more than 90. So Vp will be positive. Vp is positive means particle is moving in upward direction. So that's how we relate this formula. Now one more thing. So if I differentiate this formula once again, first differentiation what I got in this formula, dy by dt is equal to minus omega a cos kx minus omega t plus phi. This is the first differentiation equation. Second one, dy by dx is equal to k a cos kx minus omega t plus phi. That is second equation. Now once again if I differentiate first equation, what I'll get, d square y divided by dt square is equal to minus a sine kx minus omega t. Basically minus kx minus omega t plus phi. Basically integrate differentiation of cos kx minus omega t will be minus sine omega minus omega t. One more minus multiplied. Actually three minus are multiplied. So what I'll get finally, minus sine. So again if I differentiate second equation, d square y upon dx square. So what I'll get from this one, minus k square a sine kx minus omega t plus phi. I differentiate second equation. So I got equation number 3 and next equation number 4. Now if I divide these two equations, so what I get, d square upon dt square divided by d square y upon dx square, that should equal to omega square by k square. And omega by k is v. So if I simplify this equation, so d square y upon dt square is equal to v square times d square y upon dx square. So this is the condition for a progressive wave. So if any equation representing wave, it must satisfy this equation.